Hello, hi everyone. Welcome to the Student Brand. So this is our Siva sir. Today topic is light reflection and diffraction. Light reflection and refraction. Light is a form of energy which gives the sensation of sight. When light is incidenting on the surface, it reflects back. Okay, so when light incident on it, reflect back. So we will discuss about light reflection and diffraction completely. Okay, and related to this, we will do few questions also. Okay, so let's start. So now I am taking light reflection and refraction chapter. Light reflection and refraction. So light reflection and diffraction, CBSE grade 10 physics. So do like, share and subscribe to Story in the Brand. So light reflection and diffraction. Light is a form of energy which gives the sensation of sight. When light incident on the surface, it reflects back. Okay, so now you can observe here. So I'm taking this the plane surface. The light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is perpendicular to the plane surface is called normal line. The light ray which is perpendicular to the plane surface is called normal line. Okay, so this is a plane mirror. This is incident ray, reflected ray, and this one is the normal line. Okay, incident ray, reflected ray, normal line, and the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. So this angle of incidence, angle between reflected ray and normal line is called angle of reflection. And you can observe, so the light ray which is undeviated. Okay, so it's not deviating, it is undeviated line. So undeviated line, the angle between a reflected ray and undeviated line is called angle of deviation. Angle of deviation, once again you can observe here, incident ray, reflected ray, normal line, this undeviated line, undeviated line, undeviated line. So this undeviated line, or initial direction of the incident ray line, or undeviated line we can take. Okay, so incident ray, reflected ray, this is incident ray, and reflected ray, and this one is the normal. Okay, so the angle between, here you can observe the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And here you can observe this is the reflected ray, and so this is the undeviated line. So the angle between the reflected ray and undeviated line is called angle of deviation. So here you can observe this is the linear angle. So normally if you are taking the circle, so this is the circle. If you are taking circle, so that is a 360. Total is 360 degrees. So this half is 180 degrees. Half circle angle is 180 degrees. Remaining half is 180 degrees. Okay, half is 180 degrees. Remaining is half 180 degrees. Total is 360 degrees. Okay, total is 360 degrees. Yes or no? So now here you can observe. Okay, so this angle, so from, if you are taking this linear angle, this angle is 180 degrees. So that 180 degrees includes of angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay, so now we will discuss about laws of reflection. loss of reflection, loss of reflection, loss of reflection. So coming to loss of reflection are nothing but, so incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay, first point is incident ray, reflected ray, normal line. Okay, so here you can observe this incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to, second point, angle of incidence is equal to angle of reflection. These are the laws of reflection. From laws of reflection, we can conclude that, okay, so here we can observe angle of incidence plus angle of reflection plus angle of deviation equal to how much? 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. From laws of reflection, angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So we can write, instead of reflection, shall I write angle of incidence? Okay, so if I write angle of incidence, so then we'll get angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence. I hope it is very clear. Okay, so now we can also take angle of deviation equal to 180 minus 2 angle of reflection. Sir, how you are getting this one? Because instead of angle of incidence, if I write angle of reflection, instead of angle of incidence, if I write angle of reflection, I'll get the same. So I hope it is very clear, right? So this is about this is about reflection of light, angle of deviation, so angle of deviation and loss of reflection. Loss of reflection. Once again we will discuss about loss of reflection. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. And incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And angle between reflected ray and deviated line is called angle of deviation. Okay, so this is about loss of reflection. And here this the linear angle 180 degrees will be there, linear angle. So this is a linear angle I am taking. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay, so coming to loss of reflection, incident ray, reflected ray, normal line. So here you can observe incident ray, reflected ray. This incident ray, reflected ray, normal line lies on the same plane. So okay, so angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. This is the loss of reflection. So angle of here from loss of reflection, we can take angle of incident is equal to angle of reflection, right? So that this we can take angle of instead of angle of incidence, I am writing angle of reflection. So that angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. So angle of deviation equal to 180 minus 2 angle of reflection. So instead of angle of reflection, if I write angle of incidence, I'll get, instead of angle of incidence, if I write angle of reflection also, I'll get angle of deviation formula. So this is about reflection of light, and incident ray, reflected ray, normal line. So incident ray, reflected ray, normal line. So after that we discussed about angle of deviation. After that loss of reflection. After that we discussed about angle of deviation, derivation of the formula. Okay, so everything we discussed. So as of now we discussed all these points. Now we will discuss about regular reflection and irregular reflection. So regular reflection. Okay, so let's start. Chapter name is light reflection and refraction. Light reflection and refraction. CBSE grade 10 physics. Now we will discuss all these points. So let's light reflection and refraction. So refraction. Okay. Now, so regular reflection and irregular reflection will discuss. Regular reflection and irregular reflection. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface and irregular reflection takes place on rough surface. So I am taking this one. This is smooth surface. Okay, surface. Okay, incident light rays are like this. These are the incident light rays. Incident light rays. Incident light rays. Incident light rays. Reflector light rays are also parallel to each other. After reflection, these are the incident light rays are parallel to each other. Incident light rays are parallel to each other. After reflection, reflector light rays are also parallel to each other. The type of reflection is called regular reflection. Regular reflection. Okay, so here you can observe, these are incident light rays. So incident parallel light ray. Okay, so incident parallel beam, because all light rays are parallel to each other, so it's like a beam. Normally single ray is called single light ray is called ray. Single light ray is called ray. So number of light rays together is called beam. Number of light rays together is called beam. So here this is a parallel incident beam. So after reflection, so these are the reflector light rays. Those light rays are also parallel to each other. Those light rays are also parallel to each other. Incident parallel beam. Incident parallel beam. Parallel beam. So reflected. Okay, so incident light rays are parallel, then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. Okay, regular reflection. So regular reflection takes place on smooth surface and still water you can say still water on lake, and plane mirror, especially plane mirror, regular reflection takes place. Coming to irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. So I'm taking here, so like this is the surface, this is the surface. Okay, so incident light rays are parallel, but reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. So these are the incident light rays. So I'm taking like this, these are incident light rays. Okay, these incident light rays are parallel, but reflector light rays are not parallel to each other. So these light rays will be moving in different directions. Okay, so they'll move in different directions. You can observe incident light rays are parallel, but reflector light rays are not parallel to each other. So those light rays are moving in different directions. This type of reflection is called irregular reflection. Okay, so irregular reflection takes place on a rough surface. Irregular reflection. So here you can observe regular reflection takes place on smooth surface. As I said, regular reflection Regular reflection takes place on a smooth surface, that is nothing but plane mirror, and we can also say plane mirror and still lake water. So water is at still constant position, that time also regular reflection takes place. Whereas irregular reflection takes place on rough surface, because incident light rays are parallel but reflector light rays are not parallel to each other, they are moving in different directions, these are moving in different directions. Okay, so irregular reflection takes place on rough surface. Best example you can say wall and paper, even on paper also rough irregular reflection or diffused reflection. Irregular reflection is also called diffused reflection. Irregular reflection is also called diffused reflection. Okay, yes. So this is about regular reflection and irregular reflection. Now so now you can see, now regular reflection completed and irregular reflection also completed. Now we will discuss about image and object. So now you can see, so this is a plane mirror, this I am taking the plane mirror like this. Okay, so light rays are coming from source like this, these are the light rays, these are incident light rays I1 and I2. So after reflection those light rays are meeting at one point. So here after reflection those light rays are meeting at one point, here you can observe. Okay, so this thing, what is this one? So real image. Okay, I1, I2. After reflection, those light rays are meeting at one point. Okay, so that is the real image. And we are extending these light rays. So here you can observe, we are extending these incident light rays. Here also we are extending these incident light rays. So here you can say this is the virtual object. Virtual object. I hope it is very clear. So here you can see inside I1, I2, after reflection light rays are meeting at one point, their real image is there. So we are extending incident ray 1, incident ray, both are meeting at one point, their virtual image is virtual object. And here you can see one more. So light rays are coming from the point, from one point light rays are coming. Okay, so I am taking this object, this is the object, this is the real object. From here one light ray I am taking like this, another light ray I am taking like this. After reflection those are moving away from it, so if you are extending these light rays, those extended light rays, so this is the virtual image, understood? So this is the incident ray I1, I2, this is the R1 and R2, and this is the virtual image. Okay, virtual image. So now you can observe, here I am drawing. So now you can observe object and image. Object is real, image is virtual. Object is real, image is virtual. Okay, object is real, image is virtual. Object is virtual, image is real. Understood or not? Okay, so here you can observe I1, I2. After reflection those light rays are meeting at one point, so that is a real image. So why you are saying real image? Why you are saying this is a real image? Because so directly reflector light rays are meeting at one point. So here, so this is the incident ray I1, I2. After reflection those are meeting at one point, their real image is forming. So here we are extending I1, we are extending I2 also we are extending. Those two light rays are meeting at one point. Their virtual object. So that is not real image, virtual object. Okay, we are extending the incident light rays. And here you can observe the from here, if you take the candle or a bulb or a tube light like this, anything you can take. From that, so light rays are coming. Okay, light rays are coming from that source. Okay, light rays are coming from that source. Okay, after reflection, this is the R1, R2. We are extending those light rays. We are extending those light rays. Extended reflector light rays. R1, R2. R1, R2. R1, R2. Extended reflector light rays are meeting at one point. Extended light rays are meeting at one point. Their virtual image is forming. Virtual image. Virtual image. I hope it is very clear. So, are you understanding? Are you understanding my point? Okay, so be aware of it. Very, very important. Here I mentioned in the table. So you can see. So in the tabular column I mentioned. Object is real. This is the object. Object is real. Real object. Object is real. What about image? Image is virtual. Image is virtual. Object is virtual. Object is virtual. What about image? Image is real. Image is real. Real image. So object is real. Image is virtual. Object is virtual. Image is real. So these are the, okay. So real object and virtual image, virtual object and real image, vice versa. If the object is real, image is virtual. If the image is real, object is virtual. So like this. Okay. So next we will discuss about characteristics of the image formed by the plane mirror, or nature of the image formed by the plane mirror. Okay. So let's start. So this is a plane mirror like this. This is a object. Object I am taking object size of the object like here. Okay, so AB. How many light rays are required to form the image of the object? Minimum how many light rays? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays. Yes or no? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So actually, if the light ray is passing along the normal line, so if the light ray is passing along the normal line, so it moves in the same direction. If the light ray is moving along the normal line, it moves or rebounces or bounces back in the same direction. Okay, so along the normal line, if it moves in the same direction. So here also, if I am taking along like this, it will be reflected back. It will be reflected back. So here I am taking one more light ray. So I am taking one more light ray from this point. So at the edge, so if you are taking this thing, so from here you have to take light rays. Okay, from the tip of the object. So from here you have to take the light rays. From there only you have to draw the light rays. Okay, no? From the object. So here also I am taking here after reflected. So the light ray is moving away from it. And here also one more light ray. So along the line, so along the line, principal axis if you are taking, so along the line it will move. So as I said here, if the light ray is moving along the line, so it rebounces in the same direction. It rebounces in the same direction. So and one more thing I am taking here. So this reflected ray. So this incident ray, reflected ray. Now you can observe here carefully what exactly is happening. So we are extending the reflector light rays. We are extending the reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Sorry. So here you can take like this, and here also I am considering here, and here also. So here you can observe there the image is forming. Here the image is forming like this. Okay. So the image is forming here like this. So this is the A dash and B dash, A dash and B dash, A dash and B dash. A dash and B dash. Okay. So the distance between object to mirror is called object distance. The distance between object, this is the object and this one is the mirror. and this one is the image. The distance between object to mirror is called object distance, and the distance between mirror to image is called image distance. So once again, the distance between object to mirror is called object distance. The distance between mirror, this is the mirror. So the middle one is mirror, and this one is the object, and this one is the image. Okay. So here the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. First point is object is real, image is virtual. I already explained just now. Before that I mentioned in the tabular column. So I mentioned object is real, image is virtual, object is virtual, image is real. Like that I mentioned, right? So here also same thing. If the object is real, image is virtual, object is virtual, image is real. And the second one is object distance is equal to image distance. Object distance is equal to image distance. And third one, here height of the object is equal to height of the image. So this is the height or size of the object. Size of the object or height of the object is equal to height of the image. So height of the object is equal to height of the image. And the fourth one you can see, okay. So magnification of the plane mirror is +1. Magnification of the plane mirror is +1. Sir, what is magnification? Magnification is nothing but the ratio of height of the image by height of the object. Magnification is nothing but the ratio of height of the image by height of the object is called magnification. It's called magnification. And coming to the next one, lateral inversion. So what is lateral inversion? Lateral inversion is nothing but the phenomena of converting of lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So this mirror image is called lateral inversion. This mirror image is called lateral inversion. Once again you can observe here. So object distance, object is real, image is virtual, object is virtual, image is real. So you can observe object is real, image is virtual, object is virtual, image is real. And also object distance is equal to image distance. Object distance is equal to image distance. Distance between object to mirror is called object distance. Distance between mirror to image is called image distance. And magnification is +1. So what do you mean by magnification is +1? Okay, so here in plane mirror, normally magnification means so height of the image by height of the object, the ratio of height of the image by height of the object. Okay, so here what type of image will get? Virtual, erect and same size. Virtual, erect and same size image we will get in the plane mirror. So magnification is +1. Magnification is +1. And also it shows lateral inversion. What is lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. Okay, so I hope it is very clear. So this is about characteristics of the image formed by the plane mirror. So our nature of the image formed by the plane mirror. So now we will discuss about spherical mirrors. So we'll discuss about spherical mirrors. There are two types of mirrors are there: concave mirror and convex mirror. Concave mirror and convex mirror. Those are spherical mirrors. Okay, let's start. The mirror which is in the form of curved surface, the mirror which is in the form of curved surface, the mirror which is in the form of curved surface is called spherical mirror. Is called spherical mirror. Spherical mirror. There are two types of spherical mirrors. Spherical mirror. Spherical mirror. One is concave mirror. Concave mirror. And the second one is convex mirror. Okay. So concave mirror and convex mirror. So what do you mean by concave mirror? The mirror whose reflection takes place inward. The mirror whose reflection takes place inward is called concave mirror. The mirror whose reflection takes place outward is called convex mirror. Okay, so here I am taking like this. So actually is a part of this sphere. This is a part of this sphere. So we are taking small portion. We are taking small portion that is called concave mirror. So reflection takes place inward. So here, and coating will be outward. And one more thing here you can observe. One more thing you need to understand. Okay. So concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Sir, why you are calling, why you are saying, how you are saying concave mirror is also converging mirror? Why? Because whenever light rays are incidenting on it, after reflection those light rays are meeting at one point. So after reflection light rays are meeting at one point. That's why, so converging. After reflection light rays are moving, are coming closer are moving towards the principal axis, are meeting at one point. So that's why it is called converging mirror. So whereas convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. So how it will be, we will see. Convex mirror. So now you can observe here, this is a convex mirror. Convex. So actually it's a part of this sphere. So part of this sphere I am taking. Okay. So here you can take like this. Okay, it is a part of this sphere, right? So I am taking this principal axis. So coating will be inward, reflection will be outward. So after reflection, these light rays are moving away from the principal axis like this. So here also. Okay. So after reflection, those light rays are moving away from it. So we can extend this reflector light rays, or those light rays are meeting at one point. I hope it is very clear, right? Yes. Now, convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. Now we will discuss about ray rolls and image formations, everything. Okay. So thank you so much for joining and attending and listening class. So do like, share and subscribe to Student Brand. This is your Sir from Student Brand. So if you like the channel, if you like my explanation, if you like the content, please do like, share and subscribe to Student Brand and share to your friends and share to your well-wishers. Okay, so ask them to join, ask them to subscribe my channel. So please do like and share and subscribe and support my channel. So thank you so much for joining.